Time series analysis. A time series is a sequence of data points typically consisting of successive measurements made over a time interval. Examples of time series are general prices, income or expenditure over a period of time, and the daily closing value of the share prices in any stock market. Time series are very frequently plotted via line charts. Time series are used in statistics, signal processing, pattern recognition, econometrics, mathematical finance, weather forecasting, astronomy, communication engineering, and largely in any domain of applied science and engineering which involves temporal measurements, which means measurement over time period. Time series analysis comprises methods for analyzing time series data in order to extract meaningful statistics and other characteristics of the data. Time series forecasting is the use of a model to predict future values based on previously observed values.
After studying this module, we shall be able to understand the basic meaning of time series, know its applications in real life situations, and get a brief introduction to its various components and types. Every activity, be it in the academic area or in the real life situations, uses data for making efficient decisions in future. Data used is of three types: time series data, cross sectional data, and panel data. Let us now look at each of them in brief. Time series data refers to the series of data for one variable over a period of time. For example, to see the trend of inflation levels in the economy, the inflation in the past few years is collected and analyzed. Cross-sectional data refers to the data collected for more than one variables at a single point of time. For example, to analyze the standard of living of people for the year 2013 to 14, one may collect the data related to income levels, education levels, health status, etc. for the same year, that is 2013 to 14. Panel data is a multi-dimensional data for more than one variable over a period of time. In simple words, it is the combination of both time series data as well as cross-sectional data. Estimation about future is one of the most important components of economic analysis, be it for the individual welfare or welfare for the society as a whole. However, to forecast that future in the most efficient way, one needs to understand the trends in the past. As a result, the statistical data is gathered, perceived, and recorded at successive time intervals. Thus, the data collected for past continuous intervals is known as time series. Concept of time series was introduced by Angel and Granger. Granger introduced the topic in 1964 in his book, namely Spectral Analysis of Economic Time Series. It is concerned with the analysis of data which is collected over a period of time which may vary from a week to month to years. For example, the growth rate of population may be analyzed yearly. Changes in WPI inflation may be analyzed on a monthly basis. The dollar price in terms of rupee may be analyzed on a weekly basis, etc. In short, time series analysis is done to observe a pattern in the values collected for the purpose of short term or even long term forecasting. Let us have a look at some of the important definitions of time series given by renowned economists. By Peterson, a time series consists of statistical data which are collected, recorded, and observed over successive increments of time. by Morris and Hamburg. A time series is a set of statistical observations arranged in chronological order. By Wessel and Wallet, when qualitative data are arranged in the order of their occurrence, the resulting statistical series is called a time series. In terms of econometrics, example of a time series regression model is a Phillips curve. It is a curve which is static in nature, determining the relationship between inflation and unemployment. It can be written as inflation at time period t is equal to beta naught plus beta 1, unemployment at time period t plus mu t, where inflation at time period t is equal to rate of inflation at time period t. Unemployment at time period t is the rate of unemployment at the time period t, and mu t is the error term at the time period t. The term t is to be noted here. It signifies the importance of the model being static in nature, that is, both the variables, inflation rate and unemployment rate, are noted for the same time period t. In relation to business economics, the study of time series is useful in smoothing or trend assessment, in which we can analyze the trend of the past variables to undertake various business decisions in future. Accounting for seasonality, which includes the understanding of the effect on the dependent variables due to seasonality movements, is important to take efficient decisions in future. Assessment of serial correlation amongst variables is important for decision making. For example, the effect of increase in money supply on inflation can be studied by analyzing the past trends of these two variables and how does the inflation changes with the subsequent increase or decrease in the money supply. Let us study the objectives behind using time series. Time series helps in obtaining the statistical measures of data. The description may be in the form of summary statistics or graphs. It is helpful in observing the variations in the time series and further explaining the variations to understand the trend. Time series also helps in predicting the future values on the basis of past trend. Time series is helpful in controlling the variables to make the econometric models more efficient. With the help of time series analysis, the errors could be identified and necessary adjustment can be made to avoid losses. Time series serves a great amount of significance to not just economists and business people, but to scientists, astronomers, geologists, sociologists, biologists, as well as research workers. Time series helps in understanding the behavior of data in the past. Analysis of time series helps in predicting the future behavior of a variable taken into consideration. For example, the finance minister of our country always analyzes the past performance of various sectors in the economy, on the basis of which he makes the budget for the subsequent year. Future planning can be done only by forecasting the events and analyzing the relationship they have with the independent variables. For example, the sales target for employees are set based on their performance in the past. This helps the management to set achievable targets. The accomplishment can be measured only by comparing the past trends with the present. Therefore, here time series plays an important role. For example, whether the salesmen in the company achieved their targets in the entire year can be observed by studying their trends. The time series can help in comparison between the past trends, and thus conclusions can be effectively drawn from the past. For example, the Human Development Index, that is HDI, is developed by comparing host of factors of various countries together. Time series analysis can be used for census analysis, economic forecasting, utility studies, sales forecasting, budgetary analysis, workload projections, stock market analysis, inventory studies, process and quality control, and yield projections. Let us now move to the types of time series analysis. The time series can be divided into two types: univariate time series and multivariate time series. Let us now study them in detail. The series which considers only one variable, we call it as a univariate series. For example, the data on change in income level of a country over a time period will be considered as a univariate time series. A univariate time series can be mathematically expressed as yt is equal to function of yt minus 1, yt minus 2 to yt minus n plus mu t, where y is equal to income and mu t is the error term. The equation analyzes the determinants of income considering the past income and some shocks denoted by mu t. The series which considers two or more than two variables, we call it a multivariate series. For example, if we consider changes in between income levels in rural and urban areas, we call it a multivariate time series. Multivariate time series can be mathematically expressed as yt is equal to beta 1 plus beta 2 yt minus 1 plus beta 3 xt plus mu t. In the above equation, we have two variables where y is the dependent variable and x is the independent variable. The value of y is affected by two variables. One, its own lagged value, and other, the value of variable x. The error shocks are considered explicitly. Let us now look at the components of time series. The components of time series include secular trend, seasonal variations, cyclic variations, and irregular variations. Let us elaborate each in detail. Starting with secular trend series, in which measurements of a variable are done over the time periods of several years to access the long-term trends and seasonal fluctuations. Therefore, these trends are long-term in nature. They explain the basic nature of a variable to increase or decrease over a time period. Such trends are measurably reflected in population change, technological progress, and large shifts in consumer taste. Under this, there are two important points to understand. The nature of data determines whether the trend is long term in nature or not. By nature of data, it is meant that how frequently the variables change in a period of time. The longer the period, more significant is the trend. However, to compute the trend, the period should cover at least 2 to 3 cycles. It is not necessary that the increase or decrease in variables should be in the same direction throughout the period. The seasonal component of time series represents that part of variations in the time series which denote intra-year fluctuations. These variations are mostly stable over the years with respect to timings, direction, and magnitude. Therefore, these are the periodic movements taking place in a business activity which occur on a regular basis, usually a year. Thus, the time period involved in such trend is normally 12 months. The term seasonal includes variation which are periodic in nature and the cycles involved are relatively shorter in duration. The factors causing seasonal variations are climate and weather conditions like rainfall, heat, etc., have a major impact on the different sectors of the economy. The most common example is the agriculture sector, where production as well as productivity depends on the weather conditions. Certain habitual factors also lead to the seasonal variations. For example, during the festive season, there is a sudden rise in the demand for sweets. Cyclic variation is that part of the time series which represents the changes of economic activity due to recurring causes. Cyclic variation may be seasonal in nature or they may follow a business cycle like this. As we can see in the diagram, prosperity is the phase in which profits are easily made. There is considerable expansion in business activity which leads to overdevelopment. Decline occurs due to overdevelopment. There is a shortage of facilities which leads to decline in productivity. Hence, prosperity starts to decline. Depression is the situation of continuous decline in the economic activities lead to the downfall of economy, thus arousing a feeling of pessimism. However, money accumulation takes place soon, thus leading the economy to the period of improvement or recovery. Irregular variations or random variations are those which correspond to the movements that appear in an irregular fashion, usually during short periods. These variations are characterized by business activities which do not repeat themselves in a regular pattern. In simple words, they are highly unpredictable in nature. These are majorly caused by unexpected events like natural disasters, war, etc. However, it is important to recognize such movements because it helps in future analysis and in avoiding errors in economic models. Before looking at the classification of time series, let us see what is meant by term stochastic process. Stochastic process is the collection of random variables observed during a period of time. It is also known as random process. For example, we assume y as a random variable. The process of collecting the values of y during a period of time will be a stochastic process. Mathematically, it can be expressed as yt is equal to beta 1 plus beta 2 xt minus 1 plus mu t, where yt is any variable whose value is observed over time. Mu t is the error term or shock variable.
Time series can be classified into different types: a stationary process, or strictly stationary process, or a strong stationary process, which is a stochastic process whose joint probability distribution does not change when shifted in time. Consequently, parameters such as mean and variance, if they are present, also do not change over time and do not follow any trends. They are invariant of time. In time series regression analysis, we need the assumption of stationarity because the results of classical econometric theory are derived under the assumption that variables of concern are stationary and standard techniques result in invalid outcomes in the presence of non-stationarity. The time series data have a natural temporal ordering. This makes time series analysis distinct from cross-sectional studies in which there is no natural ordering of the observations. For example, explaining people's wages with reference to their respective educational levels, where the individual data could be entered in any order. We define it as cross-sectional data. Time series analysis is also distinct from a spatial data analysis where the observations typically relate to geographical locations, for example, accounting for house prices by the location as well as the intrinsic characteristics of the houses. A stochastic model for a time series will generally reflect the fact that observations that are close together in time will be more closely related than observations that are apart in time. In addition, time series models will often make use of natural one-way ordering of time so that values for a given period will be expressed as derived in some way from the past values rather than future values. Time series analysis can be applied to real valued continuous data, discrete numeric data, or discrete symbolic data. For example, sequence of characters such as letters and words in the English language.
A stochastic process is considered to be a stationary process if its mean and variance remains constant over a period of time. Additionally, the value of covariance between the two time periods will also depend on the lag between them and not on the actual time when the covariance is computed. Stationary time series is mostly used in the micro sense. For example, if we assume that there is perfect competition in the market, we are saying that there is no change in the mean and variance across that market. In simple words, we assume that all the producers charge the same price and sell a homogeneous commodity. If we explain it mathematically, the stationary time series will be that series whose mean expectation of yt is equal to mu is not a function of time. Variance, that is variance of yt, is equal to expectation of yt minus mu whole square is equal to sigma square, which is also not a function of time. Covariance, that is covariance of yt plus k comma yt is equal to gamma a b h. If a is not equal to b, then the function is known as a cross correlation function. However, if a becomes equal to b, then autocorrelation is present in the model. A stationary time series is further classified as strictly stationary and weakly stationary. It is an extreme form of time series phenomena. It takes into consideration the joint distribution of variables over a period of time. Any series yt plus 1 to yt plus n is considered to be strictly stationary if the joint distribution of the first n observations is equal to that of another set of distribution with n observations separated by a time lag, say k, that is yt plus k to yt plus k plus n. To explain it mathematically, assume we have two distributions xt1 and xt2. We introduce a lag of say k in the series. It becomes xt1 plus k and xt2 plus k. So, in a strictly stationary series, even after introducing the lag, xt1 is equal to xt1 plus k, xt2 is equal to xt2 plus k. Also, in a strictly stationary series, the continuous variable tend to be identical to the discrete variable, that is, xt is identically equal to xt, where xt is a continuous variable and xt is a discrete variable. One point to remember is that under the strictly stationary series, higher order movement will be constant. A series yt is considered to be a weak stationary series if its mean and variance are independent of time. That is, in such type of a series, it's only the mean and variance which do not change. Rest all the variables are a function of time. However, the covariance or autocovariance is a function of lag but not of time. Mathematically, it can be expressed as mean, that is expectation of yt is equal to mu, which is not a function of time. Variance, that is variance of yt, which is equal to expectation of yt minus mu whole square, is equal to sigma square, which is also not a function of time. Covariance gamma k, which can be written as expectation of yt minus mu yt plus k minus mu, where gamma k is the covariance at lag k, that is the covariance between the values of yt and yt plus k, that is between two y values k periods apart. The series is considered to be non-stationary when both mean and variance or any one of these is a function of time. In this case, accurate prediction is not possible. Hence, first the series is supposed to be converted into stationary series and then only it would be used for forecasting purposes. The most important example of non-stationary time series is a random walk model. In the real world, asset prices like exchange rates and stock prices follow a random walk process and are non-stationary in nature. A random walk is a process where the current value of the variables incorporates the lagged value of the same variable plus an error term usually known as white noise. Random walk process can be classified into two parts. First is random walk without drift, which is expressed as yt is equal to yt minus 1 plus mu t. Here, mu t is the white noise error term with mean is equal to 0 and variance is sigma square. In the random walk model, the value of y at time t is equal to its value at time t minus 1 plus a random shock. Second is random walk with drift, which can be expressed as yt is equal to delta plus yt minus 1 plus mu t. Here, delta is considered to be the drift parameter. This implies that yt would drift upward or downward depending on the value of delta being positive or negative respectively. One point to remember is that random walk model is an example of a commonly known process in econometrics, that is a unit root process. If two time series follow an independent random walk process, then the relationship between the two does not conclude us to any economic meaning. If the regression analysis is still done, then we can expect high R square, low Durbin-Watson statistics, high T ratio for slope coefficient.
To summarize, time series is an important phenomena in econometrics, extending a help in analyzing the past trends to make efficient forecast. Univariate time series analysis helps in analyzing just one variable, while multivariate time series incorporates more than one variable and thus is more helpful in econometric modeling. Time series analysis also helps in business activities, from identifying the problem to making necessary adjustments in it. Besides this, it helps majority in forecasting the events, making the decisions more profitable. Time series is classified as stationary and non-stationary. Stationary time series considers the mean and variance of the error term to be constant, leading us to calculate efficient estimators. It is further classified as strictly stationary and weakly stationary. On the other hand, non-stationary time series implies that the mean and variance of the error term are not constant over time. The difference between strictly stationary and weakly stationary is that the former treats even the covariance to be independent of the time and its lag, while the latter implies that the covariance is a function of the lag taken into consideration. While doing the regression analysis based on time series data, it is assumed that the time series is stationary. Important tests like t-test, f-test are based on this assumption only. In reality, though, most of the economic time series are non-stationary. In such a situation, it is important to convert the non-stationary series into a stationary series through appropriate measures.
To summarize, time series is an important phenomena in econometrics, extending a help in analyzing the past trends to make efficient forecast. Univariate time series analysis helps in analyzing just one variable, while multivariate time series incorporates more than one variable and thus is more helpful in econometric modeling. Time series analysis helps in business activities from identifying the problem to making necessary adjustments in it. Besides this, it helps majorly in forecasting the events, making the decisions more profitable. Time series is classified as stationary and non-stationary. Stationary time series considers the mean and variance of the error term to be constant, leading us to calculate efficient estimators. It is further classified as strictly stationary and weakly stationary. On the other hand, non-stationary time series implies that mean and variance of the error term are not constant. The difference between strictly stationary and weakly stationary is that the former treats even the covariance to be independent of time and lag, while the latter implies that the covariance is a function of lag taken into consideration. While doing the regression analysis based on the time series data, it is assumed that time series is stationary. Important tests like t-test, f-test are based on this assumption. In reality, though, most of the economic time series are non-stationary. In such a situation, it is important to convert the non-stationary series into a stationary one through appropriate measures.